So now I'm going to talk about the algorithm of the convex Hull algorithm, and the idea is to get a bunch of points, a set of points which is called P. Let's say that the P is set of points, and we want to get the convex Hull of this set of points. Here let's create a set of points. So I want the set that will enclose that set of points such that I will get a polygon which is convex and all the points will be inside those borders. And I want to get those nodes or those vertices that are on the border, which is the convex hull of the polygon. So the idea, if we now look back on the points, is to do that way. We'll start with ordering, sequencing the points. Let's call them P1, P2, P3, P4, no, based on the x-axis. So let's do something that is quite straight and without any mistakes. Okay, so you can understand this is P3, P4, P5, P6, and P7. Okay, we start with sequencing, and then we start with the first 2 points, this one and that one, and now we start to run. We define an L upper which will contain the vertices of the convex hull which is in the upper part, and we will define later the L lower which will get the vertices of the lower part, the lower half of the convex hull. So we start and say that try to go in the sequence based on the x-axis, so P1, P2, and then P3. Now, when I get to 3 points, what I check is whether a left turn had happened. Now, it can only be when I have 3 points. Now, if you look at that 3 points, you see that there is no left turn. This one and that one here, this is not a left turn, this was a right turn. So I can continue. I'm going in the clockwise direction and I can continue. Now I again fit 2 points, P3 then P4, ordered by again x-axis. So here you can see that I made a left turn. When I made left turns, what I do is just removing this point, the middle point between the 3 points, removing this middle point here. I moved it from the L upper and connecting the 2 points from here, where the middle I just threw away. Now P4, the next is P5. Again, this was a right turn. Now I get to P5 to P6. Again, if I look at the 3, now what happened is a left turn. If it is a left turn, what I should do, I should draw this point away and connect between P4 and P6. So let's draw it away. And here I draw it up. Now connect P4 and P6. Now again, we continue, no problem. There was a right turn. Great. Continue from P6 to P7. This is my last P. And this was again a left turn. If it is a left turn, again, take off the middle point in the 3 and connect the other points. And again, check, is this a right turn? The answer is yes, so save the point. Now, I get to Pn. Now I need to start working on the L lower. As you can see, I ended the L upper, which now contains all those points, P1, P2, P4, and P7. So now I have L upper, which contains the point P1, P2, P4, and P7. Great. Now I need to get what is P lower, and then we will unite those two L and get all the points on the convex hull, and that is how we will build the convex hull. Now, how will I build the L lower? I will start with the last P. Let's call it Pn for n points. In our case, it's P7 because we have 7 points, and we are going in this direction. Now, we will order the points the same based on the x-axis, but going from the end to the start. So we start with P7 and then P6 and then P5 and etc, etc. In the general case, we are talking about Pn, then Pn minus 1, then Pn minus 2, and etc, etc. Okay, because this is the P lower, so we're going to the opposite direction. But again, we just continue like in the clockwise direction. So now for P lower, let's do another maybe color. Now for P lower, I will start with P7, here it is, and go to the P previous to it. So let's go to the P6. Now this was the first two, so it's okay, we're still not checking if it's a right turn or left turn. Let's move to the other one. So this is this one. Now this is okay, this is straight line, this is not considered left turn, so it's okay. Now let's go to the other one. Let's go to P4. Great, this was a right turn, of course, this was a right turn, so this is okay. Let's continue from P4 to P3. Of course, what we did here was a left turn. This is not good, so go back, get rid of the middle point between the last 3 points, and connect now P5 with this one, moving over the middle point of the 3. Okay, so we connect this. So let's move on. So this was a right turn. Great, this was a right turn. So we can continue to P3. P3, let's consider that it was a straight line, so okay. Now from P3 we'll go to P1. Of course, we did here a left turn, not good, so go back, get rid of P2 and go in this direction. Now when we are going this direction again, we did a left turn, not good. We have those 3 last points, get rid of the middle point, so get rid of the middle point, here it is. Now P5 connected with P1, and okay, this is a right turn, we are in the clockwise direction, so this is fine. We got to the first point, so we know we are finished with the lower part. So L lower, what we've got, we can even write it down. We got that the L lower, let's call it LL, contains the points P7, P6, P5, and P1. Now, as you can see, we have duplications, P5, P7, P1, P1, P7. We can just get rid of the duplication, which are always in the the duplication are always in the those which are on the far right or the far left of the group. So we can get rid of one of them to not get duplications, always part of the corners. So now the L, which will contain all the vertices in the convex hull, will be a unison of L upper unite with L lower, and we get the L of the convex hull of our set of point, which is P, which we can say the convex hull of P, the L just contain, let's do it, P1, P2, P4, P1, P2, P4, P7, and P5, P6, P5, P6. Those are all the points that are on the convex hull. Great one. I can even do it in order because I know from here that P7 is connected to P6 to connect to P5 to connect to P1, So P7 connected to P6 connected to P5, and this will go to P1. Anyway, those are the points in the convex hull, and you saw how I did it, dividing this set of points to solving the upper part, solving the lower part by the algorithm with right turns, ordering by the x-axis which way to go, and then thinking about the clockwise direction and right turns and left turns, and for each 3 points, if the 3 points make a left turn, so and it's clockwise direction, so remove the middle point and continue with the edge points and connect them and continue and see if it goes. So you see how we backtrack and everything, and we got the convex hull and the vertices of the convex hull of this set of points. Now let's move to the algorithm itself after we understood the motivation for the algorithm, or the way the algorithm works. So let's write the algorithm is the convex hull algorithm, and we are getting again a bunch of points, a set of points which is called P. Let's call it P set of points. Now we start with, this is the input, and the output, as you can see, which is L, which will be this list vertices. It's a list of vertices of the convex hull of our set of point P. So let's start with the algorithm. The first step we're going to do is to sort by x-axis, and we will get P1 until Pn, as we did before. Now we are putting the first 2 points, P1 and P2, put it inside the L upper, because we will start with L upper. Those will be the starting points, while again P1 is the first one. And now we are going to run in a loop for we are in the third point for I equals 3 to n. Okay, and now what we're going to do is check every time how we are going. For each 3 points, for the last 3 points, we are going to check if they're making right turn. If yes, great. If no, backtrack and take off the middle point and try again. Check if it's a right or left turn and go from here. And if it is needed, backtrack again and everything until we get what we want. So what we are doing, we append the next point to again the list, and we are in the upper, so L upper, let's call it LU, because I don't want to write L upper all the time, so let's write LU. And now while I have L, which is L upper, that has more than 2 points, I can check more than 2 points. If so, I can check. If it does, so I can say and I can check the last 3 points. Last 3 points, if they make a left turn, namely not right turn, if they are not making a right turn, namely if they are not making a right turn, this is very interesting, because it says what it says. The word not right turn says that straight line is not okay. But if I have a convex hull, which is like this one, here, 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 and I have this point, so I go back and do that, but I will have a straight line, but it won't work. But straight line is not a right turn. It's very interesting, but I won't get to this generate case. But remember that we have a little problem with straight lines. It depends on how we will define the algorithm, but we may have problems with this definition of not right turn. They didn't say left turn. They said not a right turn. So while it happens, what we are going to do is to delete the middle point. So let's say delete midpoint, but which midpoint? From last three. From the last 3 points, delete the middle point. So again, if I have 3 points, it does a left turn, so I will change and just connect these two, and from this I will just throw it away. Okay, this is the idea. Now when we will finish this part, we are finished with the L upper, and now we need to create the L lower. So our next step, let's call it the next step, it's 7th step, but never mind. What I'll do now is put points Pn minus 1, which will be like we did with P1 P2, which were the first 2 points for the L upper. Now Pn minus 1 will be in the list L lower, and they are the first 2 points where Pn is the first point. As you saw, what we did is going here and here, we put it inside a lower, and this one, this is the Pn in this case, this was the first point in PL, and we continue from that one on. So this is what we are doing. Now we are running the same way, just from end to start in the L lower. So we are going from I, we start with n minus 2, as we already put n and n minus 1 inside the L lower, until we get to 1. We are going backward clockwise. Now while, again, this is the same idea, L lower contains at least 2 points, and again last 3 points, they do not make a right turn. If it happens, so I need to get the middle point out. Right turn. So again, I need to delete. So do delete the middle point, delete middle of last 3, and continue. Now note that I may have things like this, and this, and I don't know, this, and this, and this. Look at this one. I have this is the left turn. It will get off. I'll connect this. This is, let's this, I can say this is a right turn because I don't have 3 points. So here this is the right turn, so I can connect those ones. Okay, great. Now I'll get to this one. This is the right turn, so I'll get to this one. This is a left turn, so I'll go back. I will get rid of the middle one, get back, and do this one. Now I again got a left turn, so I need to go back and make this one. So you see, the backtrack can be, we are backtracking until we get something that is not the left turn. Now this is just 2 points, so we don't even can't get to the while, because we need more than 2 points. But you saw my idea that I can backtrack not only once, I can backtrack even 2, 3, whatever I need, until I get or to something that I want, a right turn, or until I get to only 2 points in the list. Okay, so this way we built, now we have the L lower, and now what we can do is to prevent that the first point and the last point in L lower and N upper, which are the same, quite the same, because remember that L upper starts with P1 and ends with Pn, and L lower starts with Pn and ends with P1, so we have an overlap. So we remove from one of them P1 and Pn. We'll remove from one of them, remove from, I don't know, let's say from L lower. Okay, and then after we do that, we will append. We'll say that the L of the convex hull of P equals L1 with L2. We will append them both, resulting in our list, and we will return this list, which is the list which contains the vertices of the convex hull of the self points. So thank you very much. This was the convex hull algorithm, and you saw how we did it. We move in the clockwise direction. By the way, the complexity, it's important, the complexity of this algorithm is O n log n. I'm not sure, but I think it is also called gram scan, but I'm not sure that it's totally defined as gram scan, but I think the other name is gram scan. Anyway, the time complexity is order of n log n, like, I don't know, sorting usually. So thank you very much. If there are any mistakes or correction, please tell me, and that's it.